That's what you're trying to say in the whole first place. Okay. This is kind of a display sample where we show clients that, in fact, you don't have to even know anything about statistics. That all you have to do is know to go to a certain table with that number, 264 degrees of freedom, and if your number in the table is larger than or smaller than the number, now you've got significant difference. You don't have no statistics for that. Okay, we talked about the two-way analysis of variance. Let's just quickly take a look at it. I saw a little bit of confusion in people's mind. We were talking about testing over interaction and all that. Let's go into it for a second. Sample effect, two-way analysis of variance, sample, subject, interaction. We also could have replications in there too. In fact, we have had replications in there in order to determine whether the judges are different from replication to replication. If that's a significant variable, you're in trouble because these are trained judges. They should not differ from replication to replication. So since we know that based on the trained judges that we have, we don't have to put that up there. We know that, in fact, that's not a source of, or it's not going to be a significant variable here. But that's not really true. The individual data will reveal this. But basically, the point I want to get across to you here is that the F ratio, usually that's what you're interested in. Your normal, if you look at the normal F ratio analysis of variance, fine, okay. You find the sample effect, the F ratio, probability, subject effect, F ratio and probability, interaction effect, and probability. You notice the subject effect is significant. In most cases, you're going to find subject effect significant. That's okay. Based on the kind of scaling procedure we use, the judge wants to play around one end of the scale and another judge wants to play around another end of the scale. They'll let him do it. The only thing that's critical is that the relationship, the relative relationship between his judgments on those samples must be the same. Follow me? If one judge says sample B is twice as much as sample A, he's down here. Another judge is up at another point in the scale, he better say the same thing. Because if not, then we're in trouble. Then we can't consider it a ratio system, have to downgrade, perhaps even down to as low as a rank order system. But we can test that out and determine whether or not we, in fact, can utilize these kinds of analyses on our data.
Your computer does all this for you?
It's a lovely thing. Yeah, in fact, the package, the sort of data that we're presenting is given to our clients, too, because we wouldn't want them to try and generate the statistics. And the display, if you're in charge of a sensory laboratory, the display that we've given you in the slides, very easy for you to use. And this is made for sensory people doing sensory evaluation. It's not made for a statistician or somebody else. It's made for people who need the data organized in a certain way so they can go right in and get the information they want and get out and make their decisions. And it's the first time, well, in fact, it's nice to see people come in and help us support people in sensory evaluation and organize things so we can understand them. No statistician. If there's a statistician here, I can't come up with my comments there. Okay, so basically what we do is the sample effect significant? Yes, it's significant. The subject, we expect it. Interaction, no. Interactions, where are they judging the same way? Yes, they're judging the same way. No significant interaction. Okay, if there were a significant too fast? F ratio for interaction 1.277, degrees of freedom 15,264. You look it up in an analysis of variance table, and it'll tell you that it's what the probability is of that. Okay. If that were significant, if interaction was significant, then I am obligated to take my mean square for my sample term and divide it not by error, but divide it by interaction. Simply, if I'm going to do that, I'm going to take sample by subject, right? That's my interaction. I'm going to divide that into sample. I've kind of, I'm going to divide that into sample. I've kind of neutralized, hopefully, dividing the sample, I'm going to neutralize the effect of the subject differences. That's basically what the F ratio, the ratios are doing for you. You're basically neutralizing the effect or getting it out of one of the sources of variance.
Do you totally disregard the error term?
Yeah, the error term is not the proper error term. In fact, error is kind of an arbitrary thing, really. You know, it's kind of arbitrary. You make assumptions that that's the best term to test your sample effect over. But we're saying, that may not be the case. That, in this case, is not the proper term because you had your sample by subject interaction. No, most people don't even pay attention to that. Good luck. What we do then is submit that to the proper testing of sample over interaction, and in this case, and in many cases, we'll find a significant interaction effect, and as you'll notice, because this number for interaction is larger, you're dividing by a larger number, what's going to happen is you're going to make smaller the F ratio for sample effect. You're going to decrease the probabilities of your finding a significant difference on samples. That's the price you pay when you have to leave your error term for another term. Just the divisor is larger in this case. So therefore, in any ratio, if you have the denominator is larger, you reduce the size of the number you're dealing with. Right? Yeah. Try it out, just on pencil and paper if you don't believe me. Okay. What happens is you pay a certain price here. And the price is that you decrease your chances of finding a significant difference. But in some cases, you'll find that you still come up with a significant difference. That means the interaction, the judges seeing things differently, still did not invalidate the differences between sample. There's still sample differences in there for you to go look at. In many cases, you'll find, in fact, you cannot make a decision, say, about the samples because, in fact, you will lose the significance. You may have had it over here. When you tested over the interaction term, you lost your significance, which simply says, game is over, folks. We cannot make a decision as to whether those samples are significantly different. The judges goofed us. The judges gave us problems. But that's good for you to know because that says, well, let's go look at the judges. Is it a training problem? Is it a scale problem? We know we got a problem there. At least it tells you. It identifies for you where you've got to go look to help solve that problem. You can't just dismiss the particular scale you're dealing with, or the judge. You know, most important, and we're finding this out more and more as I deal with various industries, various clients, find that having all the great information in the world doesn't help if you can't show other people what it does for them. If you can't present your data, whether you're a researcher in an academic institution or whether you're a researcher working for industry, you can't show people, present your information in a simple fashion. They're never going to understand it. They're not going to learn from it. If it's an industry, they won't believe you. They don't have to believe you. But what we've done with our data is try to work up a system of using a visual presentation that has a high meaning. So I could keep this slide up, and I could take this slide off in a few seconds, and you would still see the configuration, the shapes. You will remember those. In other words, it's easier for you to handle, to perceive, to handle this kind of a configuration, as opposed to if I took a bunch of bar graphs, histograms, and lined them up in a linear fashion, like horizontal, right along. Very difficult to remember all the various differences. But you'll remember the configuration here. And let's talk about this configuration very quickly, since I have a point to catch. Okay, each of these dimensions along the wheel, let's call it a wheel just for sake of want of a better term. Aftertaste, bitterness, mouthfeel, tartness, fruity. These are the dimensions a panel decided that they wanted to make measurements on. Group discussion. These are the dimensions that they could make. There may have been 5 more that were eliminated because the data analysis showed that they couldn't be used. These are the dimensions that they could make meaningful judgments on. So what we do is plot the means for each of the 2 samples. We have a test product in this case, and we have a market leader, right? Hypothetical situation. Plot the means, 0 being the center, 60 being out here the periphery. Just have to assign numbers because you want to do statistical analysis, you need numbers. Might as well use those numbers here. Okay, what about the relationship of the various spokes on the wheel? This is hypothetical, that's not real. We have real data that we'd love to show you, but it's what they call client private. Because it's very important to know what the relationship is, as it reveals a heck of a lot more about what's happening with your product perception. But basically what this says is that mouthfeel and tartness in this case, and tartness and fruitiness, are kind of closely related. How do we determine this? We have a correlation matrix, taking all of the data for each of the scales and correlating every scale with every other scale, looking at those relationships. It's very informative to know where there's high correlation, because high correlation may mean redundancy. If you have 2 scales that have a plus 0.99 correlation, it may mean, why bother using 2 scales to say the same thing? They may be saying the same thing. At least it gives you an avenue to look at. Correlation doesn't mean causation, but at least it gives you something to look at. Okay, each of these dimensions then are spread apart with reference to how they correlate to one another. Therefore, we would say that in this case, don't forget it's hypothetical. This isn't real. We had to replace the data. Okay, aftertaste in this case would be highly negatively correlated with fruitiness. Just as an example here, What that's important to know is if you have a product, let's say where there's sweetness and tartness associated, and you find that there's a high negative correlation, saying that when you increase one, it decreases the perception of the other one. The point of this is to point out the multidimensionality of a product. In the past, people thought, well, you take one attribute, like sweetness, and you change that, and that's all you're changing. You're not changing the other attributes. Forget it. Because you can change one of these dimensions, and you can watch how the whole configuration will be modified, which gets a point across. If you have a couple of experimental samples that have only been modified in sweetness, and you plot them on this kind of a diagram, the configurations will be somewhat different, enough to show you that, in fact, sweetness is not the only thing that perceptually has been modified. Physically, sweetness may be the only thing. Perceptually, maybe the whole product in general. Okay. In this case, hypothetically, what do we see? We see our market leader, and we see our test product. If we want to match up those configurations, right, we want to make, for example, our product more like the market leader, we may want to take a look at the fruitiness dimension. What does that tell us? It kind of gives us a guideline. It doesn't give us a hard and fast rule and say, this is where you want to go. It says, probably as a first thing, you may want to look at increasing the intensity of your product, but decreasing the fruitiness and the sweetness of the product. Maybe decreasing the fruitiness and the sweetness of the product might be enough to start bringing out these other dimensions, and it might not be. But at least instead of a sensory evaluation type, walking over to an R&D type and saying, you know, your product is different and these are the dimensions are different on, he at least can say, why don't you try looking at these characteristics first and making some modifications in this area first, rather than giving everything equal weight and equal importance. By looking at a configuration of this nature, it helps you to give guidance to people who are going to have to make product changes. And that's where sensory evaluation people have their toughest battle. They're supposed to be guiding. And I've gone past my time well beyond. So let's let it go.
Thank you very much, Mr. Seidel and Dr. Stone. Dr. Stone can stay a little longer, and Mr. Seidel has to catch a plane. So if any of you have informal questions you want to ask Dr. Stone, feel free to do so. Thank you, gentlemen, very much.